Example 4.1, area of a parallel plate capacitor. A parallel plate capacitor has plates that are separated by 1 millimeter. What is the area required to give this capacitor a capacitance of 1 farad? The capacitance equation is C equals Q over delta V. According to this equation, capacitance is a constant. If you increase delta V, that will increase the charge stored in the capacitor, and capacitance remains a constant. But capacitance is not a universal constant. It's a constant for a particular capacitor, but it depends on certain factors. For example, if you take a parallel plate capacitor, capacitance depends on the area of the plate. It's directly proportional to area of the plate. If you increase the area of the plate, that will increase the capacitance. Capacitance is inversely proportional to distance between the plates. If you increase the distance between the plates, that will decrease the capacitance. If you decrease the distance between the plates, that will increase the capacitance. Using these two relations, we can write the equation for capacitance. C proportional to A over D. The constant to replace the proportionality sign here is epsilon 0. So C equals epsilon 0 A over D, where epsilon 0 is the permittivity of free space. Let's use this equation to find the area of this capacitor. If you rearrange this equation, you'll get cross multiplied. You'll get CD equals epsilon 0 A, or A equals CD over epsilon 0. Capacitance is 1 farad. Distance between the plates is 1 millimeter, that is 1 times 10 to the power minus 3. Epsilon 0 is 8.85 times 10 to the power minus 12. 112,994,350.28 meter square, or 1.13 times 10 to the power of 8 meter square. To manufacture a capacitor with a capacitance of 1 farad, you need the plates with area 1.13 times 10 to the power of 8 meter square. Another question, if the two plates of a parallel plate capacitor are the same in area, the width of the plate is 12 centimeter, its length is 16 centimeter, and the distance between the plates is 15 centimeter. What is the electric capacitance of the capacitor? The equation for capacitance is C equals epsilon 0 A over D. We have the length of the plate, that is 16 centimeter, which is 0.16 meter, and its width is 12 centimeter, that is 0.12 meters. Area, so this is a parallel plate capacitor. The shape of the plate is rectangle. The area of a rectangle is length into width. So area is 0.16 times 0.12. 0.0192 meter square. Let's substitute in our main equation for capacitance. C equals epsilon 0 is 8.85 times 10 to the power minus 12. Area is 0.0192 over distance between the plates is 15 centimeter, so 0.15 meter. 1.13 times 10 to the power minus 12 farads, or 1.13 picofarads.